All right, these are the 5-6 notes. Our topic today is solving quadratic equations. It's really going to be sort of a recycle of some of the stuff earlier in the chapter that we did. We've talked about graphs. We've talked about doing complete the square, using the quadratic formula, and even factoring. The whole goal today is to do the solving problems. We have done problems in the earlier sections that asked you guys to find zeros, and actually finding zeros and solving are really interchangeable ideas or concepts, so some of this will seem like you've done it before. But just get a little more specific about the different ways to solve and then group it all into one set of notes, which is always good to do. We're going to have different versions of the quadratic equation as we're going through. So remember our forms, always good to know which one is which. So let's just kind of quickly categorize. There's general, there's vertex, and there's factored. And again, that'll just sort of depend on what's going on in the problem, why we'd want it in a certain form, or where we're going to go from that form to solve the problem. So let's get into different solving methods. There really are three. We're going to start with factoring. Factoring actually should always be your first check in any quadratic problem that asks you to solve. You want to check, can I do it by factoring? Factoring should be your easiest method. Complete the square and quadratic formula are not necessarily difficult, but they're just a little more work to doing those problems. And there are reasons why we would do these two, and mainly because you can factor. So always start by can I factor, and then if you can't, these are kind of your backup methods. And again, remember our forms. So let's do the factoring first. When your x squared term has got a 1 out front, then we got a really basic setup to start. So I'll always do x and x because that's going to give me my first term x squared. Then I want to look at the factors of this number, so I'll probably just make a mental list, but there it is. And then in this list are the pairs of factors that give me 18. Of those pairs, I want to find the combination that would produce the middle term. It's usually pretty easy to pick out. 1 and 18, 2 and 9, those are no's. I can't do plus, add or subtract, I should say, these pairs and get that number, but 3 and 6 I definitely can. So 3 and 6 is my choice, and then how do I get my signs right? Well, that depends on the sign of the middle term. Whatever the middle term sign is, I want the larger of these two numbers to have that same sign. So 6 should be negative. And then I can always just check to make sure I got this right by a little bit of FOIL, or check my outside inside. Outside being negative 6x, inside being positive 3x, it definitely gives me negative 3, and I'm good to go. Now, this is not the solving, this is the factoring. The solving is the next step, so this kind of gets you like halfway. But then just set your factors individually equal to 0, a little bit of basic algebra, really easy. Get your solutions x equals. So that's solving by factoring. So it's really factor first, then comes your solving. It's pretty much the same thing over here. Let's just run through another quick example where we've got an x squared term that's got a lead coefficient of 1 out front. So that gives me a basic setup of x and x. I look at the factors of 8. So again, kind of a mental list in your head. Check out the pairs. Of those pairs, which ones produce the middle term? Well, clearly it's 2 and 4, right? You can't take 1 and 8 and get a 6, but you can take 2 and 4 and get a 6 with the right signs. The fact that this is all positive means we're going to go positive and positive, and then set my factors equal to 0 and solve them individually. Again, a little bit of basic algebra and you got it. So solving by factoring is actually really easy. It's probably the factoring part. Make sure you get your factors right. This part down here, pretty simple to do. Now the difference in these two problems that are lead coefficient or number out in front of our x squared term is not a 1. But the fact that it's 2 and 7, that still makes a pretty easy start. So I'm going to set it up as 2x and 1x because that's really the only factors at 2. And then I got to check it in combination with 5, and we'll do that in a second. But at least my choices in both cases, my number out front and my constant, my last term, very simple, right? There's only factors of 2 and 1 and 5 and 1 to even begin with. But I do have to figure out which pair goes with which. So I'm going to start by just doing it both directions. I'm going to drop this down and just kind of check my outside inside. What I'll notice here is that I got 2 on the outside, 5 on the inside, and 2 and 5 cannot give me a 9 no matter what I try, so those are really out. So I have to get that pair out of there. Let's drop in the other pair and see if that does the job. So dropping that pair, now I got 10 on the outside, 1 on the inside. Well, 10 and 1 with the right signs definitely give me 9, and that's just a matter of which one do I need to be positive. I need the 10 to be positive. So I get my signs in there. So I'm going to go negative, positive, that gives me my positive 10, negative 1, which is a positive 9. Then again, set your factors individually equal to 0 and solve. A little bit of basic algebra, and you got it. All right, last one. Well, 7 again really only has choices of 7 and 1, and 1 only has choices of 1 and 1, so there really is no choices here of how I set it up. It's just a matter of will it factor or not, and it will if I do the right signs here. So negative, negative would give me negative 7 on the outside, negative 1 on the inside. Total of negative 8, I got it. Set my factors individually equal to 0 and solve, and there you go. So solving by factoring, fairly simple. Really the only catch I see here is that you guys, are you going to get your factors correct? That's going to basically be everything, and then after that, again, the algebra is pretty simple. Okay, let's switch over to multiplying for just a minute. We just want to talk about a special factoring pattern. So this will also be something that will help you recognize when you have a unique kind of factoring and then speed up your work for that particular problem. But before we do the factoring over here, we're going to start by doing the multiplication. So remember, you got two options here. You can FOIL or box. I think either one is fine. So I'm going to pop them both up, and I don't really care how you guys do it, right? That's your choice, kind of a personal preference at this point. But whether you FOIL it out or you box, remember how box works is you take each of these times each of these in combination. So x and x squared, x times -2, 2 times x, 2 times -2, and so on. But what's unique about this problem is you notice the blue terms are plus and minus of the same term, so they're going to drop. So all you're going to be left with is the x squared minus 4. Now, if you just go right over to this problem and work it in reverse, let's say I'm starting here. So I'm starting here and I ask you what the factors are. Then there's a unique kind of factoring thing going on. So when I have x squared minus, this is a unique number, it's called a perfect square, I'll have plus and minus of the same factor. We'll talk about that again here in just a minute. Let's try another one. So again, I will do foiling or box, your choice. So FOIL or the box method, it's up to you guys. Again, I notice my inside outside are the plus and minus of the same term, so they would drop out, leave me with just that. Now again, if I'm just working this problem in reverse and I start here, then my factors would be. So we're trying to get you to do here is identify a unique kind of factoring pattern. These numbers, 4 and 64, and down here 49 are perfect squares. And when you have x squared, no middle term, which means you have no like bx term, and then a perfect square last term, you'll have plus and minus of the same factor, which means the factoring of these should go real quick. You don't have to sit there and do any kind of trial and error. There's no list you got to put off to the side. You just got to go through and answer the question. So the pattern looks like this. A squared minus b squared produces an a plus b and an a minus b factor. Now, as you look at the problem, the first thing I suppose is like, how do I know that's what it is? Well, I ask myself kind of a simple question. What would I square to get x squared? What would I square to get 49? And the answer is, of course, x for that one and 7 for that one. This is not to be done on paper, but when you ask yourself this simple question, what you're figuring out is what you want to call the a and the b if we're kind of working off of that pattern. And so now I got it, and I can go ahead and do x plus 7, x minus 7. And now you're back to the idea of solving, set your factors individually equal to 0, a little bit of basic algebra, and you got it. This one's got a small difference to it with a 3 out front, so we're going to talk about a couple things you can do here. Typically we'd say, well, factor it out, and that's fine. I can pull that 3 out front, so I can do that. I can also, on the other hand, pull it out front, but then get rid of it. So we're going to kind of do a side-by-side comparison of should I bring it with or not. So if I bring it with, that's fine. I'm still going to work on this. Over here, I'm going to say let's get rid of it for a second. So my difference is I brought the 3 with, factored out front and left it there, or I divided it out, just kind of gone, got rid of it right away, which I can do too. Now, as far as continuing on, I still got to ask myself the question about the x squared minus 9, which fits into this pattern. And so the question is, what would I square? Well, that's going to be x and 3. And at this point, I've either got this set with a 3 that came with me, or I've got this set. Now, the difference really is not much, but it's like solution-wise, what about that number? And I'll tell you what, that number is not part of the solution. The solutions have to come from the factors. In other words, they got to be attached to x. That's not attached to x. So if it's me doing this problem, I think I would probably go take the 3 out, like divide it out first, factor it out, and then just divide it gone from the problem. So I'm not tempted to grab that number there and say, now this is coincidental here that number happens to be one of these numbers, but it could very well be something different, and you don't want to write that number down as a solution. So you sort of got 2 ways to go. That's up to you, I guess. If you bring the 3 with, just don't bring it into the solution part of the problem. Okay, so that's a unique kind of factoring, and once you get used to this and you see numbers like this, you'll go real quick to probably right here, no sweat, because you get used to the pattern of that factoring. All right, let's shift over to complete the square for a little bit. Now, the reason we would do the next 2 methods, complete the square and quadratic formula, is because our problem does not factor. So that's the first thing you want to check. Remember, check factoring right away. If it factors, of course, you want to do that because that's easier. If it doesn't factor, then you're going to basically have to pick, do I want to complete the square or quadratic formula? Now, for this one, I'm going to check the factoring out. Turns out I only have factors of 1 and 3, so that's what I've got here. And can I get a -4 if I have 1 and 3 as my outside inside? Now, actually, it turns out here you can. So this one does factor, which means we could just be done and say that's it. Solve my 2 factors. Set these 2 factors individually equal to 0. You'd get 1 and 3 as solutions. But we're going to do it with complete the square so we can practice the process. And then when we get done, you'll see how I got those 2 solutions. And also, this is something to think about. If you just dive in and do complete the square, you do all this work and you get to the end and you get 2 whole number answers, that means it would have factored. So again, factoring is always first. Then I go to other methods. But again, let's run through the process to remind you guys how it works. So remember the process from previous notes. You take that constant, that number term, you slide it off to the side. Then we're going to go half the middle term squared. But when you add that 4 in, remember you got to counterbalance it. So that red is the counterbalance to that number. The 3 numbers in blue are going to be our unique factoring where those three produce two identical factors. So if I asked you just a straightforward factor those three, you would get x minus 2, x minus 2. Now, two reds we combine as a single number. Then, because we're trying to, vertex form is where we're headed when we do complete the square, we don't want to keep it as two factors identical, but go as a single factor squared. Then the solving comes in from here on in. So really up to this point, we've just got the format of in vertex form, so we can solve, and solve by taking the square root is where we're headed with this. Okay, so let's get into that process. So complete the square, done, now time to solve. So a little bit of basic algebra, let's move our -1 to the other side, so add it over to the other side. We know we got to get rid of a squared, so to get rid of a squared, we're going to pull in our square root. Remember that when you are solving a problem and along the way you take the square root, that creates a plus minus situation. And then the last little bit of this is get x by itself, so move that x over. Now you'll notice here that the x solutions, 2 plus and minus 1, right? That's 3 and 1, which is actually what we would have got from the original factors. So this one did factor, but I wanted to show you kind of both. And again, to talk about if you were doing all this work and you got to this and it happened that you got whole numbers, that means it would have actually factored. So sometimes you go off another method not realizing. That's why I say always check factoring. Okay, so let's check out the next one. Does it factor? Now I took the factors of 8, 1 and 8, 2 and 4, and set up some combinations here for us. If we check our outside-inside terms, our red terms, 8 and 1 don't produce a 10, 4 and 2 don't produce a 10. So this really is a no, so now we're off and completing the square. So again, slide your number term off to the side. That's the start. Get yourself set up, half the middle term squared, counterbalance. So we want to offset that new number that we just put in, so there's the counterbalance. Take your 3 in blue and rewrite them as two identical factors. As a reminder, right? The reason I always like to write this down is because that actually is the number in my factor. And then my reds combined as one number. And then the two terms, again, sorry, two factors that are identical are going to go down to a single factor squared. Complete the square is now done. You've got it in the format that we're looking for, which is vertex form, which is nice for solving because now you can go through and do that little bit of algebra like you saw on this side. So we're going to go ahead and do that. Move the 17 to the other side. Now we got to get rid of our squared, so that brings in our square root. Remember, when you do square root in the process of solving, that creates a plus minus situation. And then subtract that 5 to the other side. And then in this case, you'd probably go to a calculator and finish it off with -5 plus root 17, -5 minus root 17. Get your two solutions. Okay, let's wrap it up with talking about the quadratic formula. Now we're going to do a little sidestep for a second and hit discriminant. Discriminant is just part of the quadratic formula, but it tells us something about the type of solutions we're going to get and how many. So the discriminant is what sits under the square root in the bigger quadratic formula. So just b squared minus 4ac. And the idea of how these produce certain types of solutions is based on if it's positive, 0, or negative. So the reason behind that's pretty easy. Let's pop up just kind of a skeleton outline of the quadratic formula. And if I dump in these numbers and put them under the root, because that's where the discriminant sits, it sits under the root, and I just reason out a little bit, if that number is positive, number plus and minus number divided by number, well, plus and minus creates 2, and they're real. Now drop a 0 in there and see what that does. Well, drop that 0 in there. What essentially 0 does is the square root of 0 is 0, so you have this number over this number, and this is all gone. Well, this number over this number produces one solution, because the plus and minus disappears. And then if you go negative, well, that's the I, so that brings in our complex numbers, but we still got plus and minus, so we still got two solutions going on. So there's the reasoning, just like what does it tell me based on where it sits in the quadratic formula? It's easy enough to calculate. So here's b squared minus 4ac in all cases. I'm going to just bring them up here quick. Pop in my b, a, and c, b, a, and c, and b, a, and c. Then, some quick calculations, so nothing too crazy here, just do some basic calculation. And then once I get that number, which is my discriminant right there, then that tells me something about solutions, because it's positive, 2 real, because it's 0, 1 real, because it's negative, 2 complex. Another good way to think about this too is what does that mean in terms of a graph and x-intercepts, because this would tell us something about the number of intercepts we'd have, which corresponds to the number of solutions. So what does it mean graphically? Well, 2 real means 2 x-intercepts, 1 real means 1 x-intercept, and 2 complex means no x-intercepts. So you may be asked to actually interpret this idea of discriminant from a graph, and there's the visual connection to that. So the last concept to hit is the quadratic formula for the purpose of solving. Again, these would be problems where we couldn't factor, so we'd want to check that out. It also doesn't hurt to do the discriminant too, just to kind of see what kind of solutions you would expect. So what I've popped up here is the discriminant work in both cases. So we got a positive discriminant, which means 2 real. We got a negative discriminant over here, which means 2 complex. Got the factoring set up here just to check it out. Turns out neither one factors. So 6 can't give us a 4, and 14 can't give us a 6, and there's the work for that. We're going to kind of cruise along a little bit. Drop your numbers in. Let's just go side by side here. Do a little bit of cleanup. Do a little bit of cleanup. And then we're going to simplify that root. So we talked about that in earlier sets of notes, so let's do that side by side. and then go to a little bit more simplifying, and then finally wrap it up with solutions. You'll notice your negative produced an I, so we're going to leave our answers like that. And here we've got